In this video, we are going to talk about speed and velocity. Let's start with speed. Speed is defined as the rate at which distance is traveled, and to calculate the average speed, it is the total distance divided by the total time. Instantaneous speed is another term you may hear, and it specifically refers to a speed at a particular instant. A clear example of this is the speedometers in cars. Let's do a quick example using the speed equation. A car is moving at a constant speed. If the car traveled a distance of 60 meters in 4 seconds, find the speed of the car. For part A, we immediately know how far the car traveled and how long it took. So this is a quick matter of taking 60 meters and dividing by 4 seconds, which gives us a speed of 15 meters per second. The problem is extended. At the 60-meter mark, the car suddenly slows down to a rest over 3.5 seconds and covers another 15 meters in doing so. Find the average speed of the car over the course of the entire problem. Remember, average speed is about the total distance traveled over total time. The total distance is the 60 meters traveled earlier, added with 15 meters while slowing down. The total time is the 4 seconds from earlier plus the 3.5 seconds slowing down. This gives us 75 meters over 7.5 seconds. The average speed comes out to be 10 meters per second. Let's move on to velocity. Average velocity is defined as the change in position divided by the change in time. If you recall, change in position is the definition of displacement. The abbreviated version for the average velocity equation is delta x over delta t. You'll notice that velocity has a vector notation over it, which implies that velocity includes direction. Instantaneous velocity is how fast something is moving at a particular time with a direction. Think of a speedometer paired up with a compass. Let's try an example of velocity. A bike rider travels 30 meters east, turns around, and rides 18 meters west in 30 seconds. What is the average velocity? To calculate average velocity, we need to determine the displacement and change in time. The time is straightforward, as the entire thing is 30 seconds. The displacement is about how far you are from where you started. It might be clear if we draw this out. So the biker travels 30 meters east, and then the biker travels 18 meters west. How far is the biker from the starting point? Based off this visual, we can determine that the biker is 12 meters east from the starting point. Another way to solve for displacement is through its equation. Displacement is defined also by final position minus starting position. The starting position would be here, which we can call the 0 meter mark. The final position would be here, which we can call the 12 meter mark. This is where the biker stops. This then just becomes an algebraic calculation of 12 meter minus 0 meters, which gives a displacement of positive 12 meters. Let's finish our velocity example. Since we know the displacement to be 12 meters east and the time to be 30 seconds, the average velocity is 0.4 meters per second east. This concludes the lesson on speed and velocity. Thanks for watching, and I hope you found it helpful.